Is the screen visible?
Yes, ma'am.
Okay, so I am just starting a discussion with some arbitrary question chosen and given to me for discussion of for today. So going with paper one first. So here the chosen questions are basically. Scroll down. Okay, let's start with question number 23. Okay, so it says that suppose a random variable x has mean 12 and the bound given by Chebyshev's inequality for the probability 2 less than x less than 22 is greater than equals to 3 by 4. We need to find expectation of x square is equals to how much. Okay, so and the mean is 12, that is mu is equals to 12, and basically variance is not known. We need to find expectation of x square is equals to how much, and the bound basically 1 minus 1 by t square is equals to 3 by 4. Okay, so can you please tell me the Chebyshev's inequality? Anyone who can tell me the Chebyshev's inequality?
Mod of x minus mu less than or equal to
T
here
sigma
something.
is less than equals to 1 minus 1 by t square, am I right?
I'm greater than.
Sorry, this is greater than equals to 1 minus 1 by t square, am I right?
Yes, ma'am.
So that actually gives me minus of t sigma less than equals to x minus mu less than equals to t sigma is greater than equals to 1 minus 1 by t square. That implies probability minus of t sigma plus mu less than equals to x less than equals to mu plus t sigma is greater than equals to 1 by minus 1 by t square. So value given over here is actually what you can see is 2, 22, 3 by 4 and 12. So basically this is probability 2 less than equals to x less than equals to 22 is greater than equals to 3 by 4. This is actually given. So I can actually write mu minus t sigma is equals to 2, mu plus t sigma is equals to 22, 1 minus 1 by t square is equals to 3 by 4. And we know mu equals to is given to be 12 is equals to 12. From over here, we can actually solve for t and sigma. Many informations are given over here. Here, 1 minus 3 by 4 gives me basically 1 by t square. That is 1 by 4 is equals to 1 by t square. That gives me t square is equals to 4 basically. So, mu plus minus t sigma. So, basically 2 mu gives me 24. So obviously that is also satisfying mu equals to 12. And if I can take out the value of that gives me t equals to plus minus 2. So t mu, and if I wanted to find out the value of sigma, so I can put it over any over here. So suppose I am choosing particularly this equation. So sigma is equals to 22 minus mu by t, that is equals to 22 minus 12 divided by plus 2 I am going to take obviously because sigmas are always positive. So basically 22 minus 12, that is going to give me 10 by 2, that is equals to 5, which is greater than 0. So I am getting the set of value t equals to 2, mu equals to 12 and sigma is equals to 5. So if sigma is square is equals to 25, then expectation of x square minus e square x is equals to 25. And what is my e square x? My e square x is nothing but my mu square, that is equals to 25. That is expectation of x square is equals to 25 plus 12 square, that is 25 plus 144, that is 169. So the answer is D. Is it okay?
Yes, ma'am.
Shall I repeat or is it okay for everyone? Okay, next going for this particular sum, this 26. Okay, here they are saying that Xn is a sequence of independent and identically distributed random variables. So, informations given is Xn IRD sequence, expectation of x1 is equals to 1. That means obviously for all the xi's it's 1 since they are IID. Expectation of x1 to the power 4 is finite, that is up to order 4 they exist and finite, and this particular expression having basically tends to normal 0 1 in distribution. So you need to find variance of x1 is equals to how much. So basically we need to find the distribution of this particular setup, that is x1 square minus plus x2 square plus x3 square plus xn square minus 5n divided by this. So have to find out this is actually my suppose say some tn. So I have to find out this expectation of tn, this variance of tn, and then I have to proceed. Okay, so the so I'm giving a hint over here, not doing the whole sum. What you have to do, you have to find out this expectation of Tn, this variance of Tn, and you have to use this CLT law, like expectation of this Tn minus E of Tn by square root of V of Tn tens distribution to normal 0 1. By using this you can use this, and basically from there you will be finding variance of x1. First you assume this to be sigma, and this over here the values of this expectation of tn and v of tn is given, and you compare them and you find out the value of sigma as well. Okay, next going for the next sum, this one. Let y1 and y2 be independent random variables defined as y1 is equals to 2x1 plus 3x2 and y2 is equals to x1 plus 2x2. Let me write this. Y1, y2, 2x1 plus 3x2, and this is x1 plus 2x2. So they are basically independent, and they are saying that for the variance of y1 is 72 and variance of y2 is 25, while x1 and x2 are also independent. So these are one point, x1 and x2 are also independent, and variance of y1 is given and variance of y2 is also given. Let me check the values again. Y1 is 72 and 25. These are the informations given to me. Now they are asking to find variance of 2 by 3 x1 minus 4 x2. Variance of 2 by 3 x1 minus 4 x2. So obviously when I am going to find variance of y1, I will be writing variance of y1 is equals to 72. That is going to give me variance of the expression of y1 is basically 2x1 plus 3x2. So 2x1 plus 3x2 is equals to 72. since x1 and x2 are independent, so x1 and x2 are independent, implies covariance of x1 x2 is equals to 0. So if I break up this formula, 4 into variance of x1 plus 9 into variance of x2 plus 2 into 6 covariance x1 x2 is equals to 72. So this portion actually gives me 0. So whole portion becomes 0. So basically 4 into variance of x1 plus 9 into variance of x2 is equals to 72. This is going to be my first equation. Next, going for variance of y2 is equals to, let me check the value, is 25 and it is x1 plus 2x2 is 25. In the similar logic, we will be getting variance of x1 plus 4 variance of x2 plus 2 into twice covariance x1 x2 is equals to 25. That is variance of x1 plus 4 variance of x2 is equals to 25. This is my second equation. Now I have to solve 1 and 2 to get the values of variance of x1 and variance of x2. So 1 was what? 4 variance of x1 plus 9 variance of x2. 4 variance of x1 plus 9 variance of x2 is equals to 72. This was my equation 1, and my equation 2 was variance of x1 plus 4 variance of x2 is equals to 25. I am multiplying equation 2 with 4. So using another color. So that is 4 into this into 4 into 4, and then subtracting. So this is my equation 1 and this is my equation 3. How I am getting equation 3? Equation 3 is equals to equation 2 into 4. This is how I have obtained equation 3. Now what I am doing? I am actually doing equation 3 minus equation 1. That is going to give me 16 minus 9 variance of x2 is equals to 25 into 4 minus 72. That is how much? 7 into variance of x2 minus 100 minus 72. 100 minus 72 is equals to, tell me the value of variance of x2.
4, ma'am.
4. Good. Variance of x2 is equals to 4. That is going to be basically 28. So that is equals to 4. So variance of x2 we have obtained. Let it be star. Next, we can take equation number 2 itself. So for equation 2 was variance of x1 plus variance of x2 is equals to 25. So equation 2 implies variance of x1 plus 4 variance of x2 is equals to 25 is going to give me variance of x1 is equals to 25 minus 4 into 4 by star. That is 25 minus 16, that is equals to 9. So variance of x1 is equals to 9. That is going to give me my second equation. So I have obtained variance of x1 and variance of x2. Now I need to obtain this variance of 2 by 3 x1 minus 4 x2. Now variance of 2 by 3 x1 minus 4 x2 is basically equals to 2 by 3 whole square variance of x1 plus minus 4 whole square variance of x2 plus twice 2 by 3 into minus 4 into covariance x1, x2. Since this portion is equals to 0, so particularly this whole portion will become 0 and we will be having 2 by 3 whole square into variance of x1 plus 4 square into variance of x2. And this is 4 by 9 into 4 plus 16 into what was variance of x2? 9. It's 16 by 9 plus 16 into 9. So tell me the value. That will come around 145.778. I am using a calculator. So 145.778 approx. So obviously here the not in point, the value is, wait.
Ma'am, you have written the wrong value of variance of x1 and x2. You have just interchanged the value. Variance
Oh,
of
sorry,
x1 is,
sorry. Ah, that's why. I think this is 9 and this is 4, right?
yes, ma'am.
Ah, this will cancel out. That's why. Now write the value. You calculate it. I'm leaving the calculation on you guys.
Ma'am, it's 68.
68. That is option D. Thank you. Okay, moving on to the next question. Shall I move on or shall I wait?
Ma'am, 29th.
29. Okay, let me finish up the marked question. Can I come back next then actually?
Okay, ma'am.
Where was I? In question number 30. Okay, can you tell me the formula of this skewness and kurtosis? Yes, anyone who can tell me the formula of skewness and kurtosis?
Ma'am, skewness is mu 3 upon में mu 2 की power 3 by 2.
Oh, not that formula. Basically, for binomial
With
distribution, what is the
binomial
formula?
distribution. Uh,
Suppose, okay, let me start with this. Suppose x is a random variable following binomial NP distribution. So for gamma 1, what will be the formula? And for gamma 2, what will be the formula? The general formula what you said is absolutely correct, but since it's an objective paper, so if you try to derive that at like in the like when you're going to give the exam in the spot, you have to derive it. It's very difficult for you to derive it, so you have to remember this formula, what will be gamma 1 and gamma 2.
okay, ma'am.
So can you now tell me what is gamma 1 and gamma 2? Okay, this is coefficient of skewness. This is gamma 1 called coefficient of skewness. Like you said, the formula is mu 3 by mu 2 to the power 3 by 2, right? And what is my gamma 2? This is coefficient of kurtosis, and the formula is, what did you say the formula is? Mu 4 by mu 2 square. Am I right? If I heard you correctly, basically. So for binomial NP distribution, my gamma 1 takes the value 1 minus 2p by square root of NPQ, and gamma 2 takes the value 1 minus 6pq by NPQ. You have to remember these two for different distributions as well. Here they have given binomial, they might give you for other distributions as well. Okay, so the skewness and kurtosis, gamma 1 is 1 by 6, gamma 2 is minus 1 by 12, and the binomial distribution parameters n by 3, what is the value of n and p respectively. So we can proceed for this. So this is actually equals to 1 by 6 and minus 1 by 12. So 1 by 6 and this is minus 1 by 12. Okay. So obviously there are not three unknown quantities. The unknown quantities are basically two, because we know one formula that p plus q is equals to 1 gives me q is equals to 1 minus p. So I can rewrite these two things, especially the first one, that is 1 minus 2p by np into 1 minus p, that is equals to 1 by 6, that is my equation 1, and 1 minus 6p into 1 minus p by np into 1 minus p, that is equals to minus 1 by 12. That will be my equation 2. Now we are going to solve these two equations. Okay, can you solve and tell me the value of n and p? See very carefully, both for both the cases the denominator are actually same, and this is like a square root is over here and the square root is not over here. So I can do a 1 square is going to give me like 1 minus 2p whole square by np into 1 minus p, that is equals to 1 by 36. Let me name this as 3. Okay, so then 3 minus 2, I can do 3 minus 2. So I can perform 3 minus 2, that is going to give me 1 minus 2p whole square minus 1 minus 6p into 1 minus p divided by np into 1 minus p, that is 1 by 36 plus 1 by 12, because minus minus will give me a plus over here. Now I can proceed. 1 plus 4p square minus 4p minus, within the bracket it will give me 1 minus 6p uh, minus, and minus is going to give me plus 6p square by np into 1 minus p, and that is going to give me how much? 1 by 36 plus 3 by 36. Just for easy sake of the calculation, I am just writing this. So that is going to give me 1 plus 4p square minus 4p minus 1 plus 6p minus 6p square by np into 1 minus p, that is equals to 4 by 36. This one cancels out. This 6p square minus 4p square is going to give me minus 2p square, and this 6p minus 4p is going to give me 2p, and this is np into 1 minus p, that is 4 by 36. Again we can cancel out 2 from both sides, that is p into 1 minus p by n into p into 1 minus p, that is equals to 2 by 36. So 1 by n is equals to 2 by 36. So that implies n equals to 36 by 2. That is basically, what is 36 by 2?
18, ma'am.
So my size is 18. So n is equals to 18. This is my first answer. So whenever I am searching over here, I can exactly reject option A and D, and I can go with option B and C, any one of them. Now I need to choose the value of P. Okay. Now going for any one equation, I will be choosing equation 1 obviously, which is the easiest one. 1 minus 2p by np 1 minus p is equals to 1 by 6. So equation 1 gives me 1 minus 2p by np into 1 minus p, that is equals to 1 by 6. So I am putting the value of n over here. So that is going to give me 1 minus 2p into 6, that is equals to 18 into p into 1 minus p, this thing. Okay. So like basically we can't do a square root of this thing, but what we can do the whole square on both sides. That what we can basically do. So we will be doing 1 plus 2p square minus 4p into 6, and we will be doing 18 into p minus p square. So 6, now we can cancel this thing. 1 minus 2p square minus 4p is equals to 3p minus 3p square. Now we will be putting everything on this side, and we will be getting 1 minus 2p square minus 4p plus 3p square minus 3p is equals to 0. Then this calculation is going to give me p square minus 7p plus 1 is equals to 0. Can you solve and tell me the value of p from over here? You need to use Sridhar Acharya, obviously. To get the value of p. If you can solve this, you will see. Okay, first you try this, then I will tell you. Okay, I hope you will be able to solve. So if you solve it, you will be seeing that you will be getting p equals to 1 by 3, so that your answer is B. Obviously, there will be other value, but you have to accept this one. So P will be 1 by 3. So option B is your answer. Okay. Moving on to other questions. Okay. Question number 33. So they are saying that mean and variance of a chi-square distribution are not same. The sum of two chi-square variates is also a chi-square variate. So they are asking for, suppose I have chi-square with n degrees of freedom. So obviously the mean and variance are not same. This is their first claim. And the sum of the chi-square variates, like if we have two variables having chi-square, then their sum will also be a chi-square variate. So whether the additive property is satisfied or not. Okay, so that is they wanted to say. So which consider the statement, which of the following statement is or are correct basically. So basically mean and variance of a chi-square distribution are not same. This is absolutely correct. And for two chi-square variates, it is also a chi-square variate. Is it correct? So one is, if
Yes,
one
ma'am.
is, yes, it's correct. Are you sure? It is correct, only the variates are independent, which is not mentioned. So only one will be correct. It is true, but if x and y are two variates, only if they are independent, then only it will happen. Okay, next, let us start example 39. The mean deviation of x from its mean is 5. Then the mean deviation of y equals to 2x plus 3 from its mean is how much? So let me write this. They are saying the mean deviation of x from its mean is 5. So I am writing MD of x with its mean x bar is equals to 5. Okay. So they are asking MD of y from its mean will be how much? MD of y from its mean y bar will be how much, where y equals to 2x plus 3. Okay, so basically some x1, x2, xn, x values are given and their mean deviation about mean x bar is 5 is given, and we have made a change of we have made a transformation, and on the basis of this transformation we have got a new set of variables y where the transformation is absolutely like this. Okay, so I need to find out the mean deviation about y with respect to the mean of y. So obviously I don't know the mean of x, but I know the md of x bar. So can you tell me the md of y, this variable, like I want to find out this answer by using the property of mean deviation.
13, ma'am.
Sorry.
13, ma'am.
13. How can you get 13? See, for this, actually, the property says that mean deviation of y is equals to this. It depends only on this, the change of scale, not on change of origin. Doesn't depend on change of origin, depends on change of scale only. So this will be your answer. So basically, if I like take the reverse thing, so obviously MD of y will be 2 into 5, that is equals to 10. So my answer is this. C. Is it okay? Okay, let's move on to paper 2. No more question over here which are marked basically. Okay, start with question number 17. Okay, they are saying that consider the following statement in respect of an estimated t for the parameter theta. So, if t is unbiased for theta, then t square will be also unbiased for theta square. If t is consistent for theta, then t square will also be consistent for theta square. And also, if t is sufficient for theta, then t square will also be sufficient for theta square. So which of the above statement or statements are correct basically? So all the above, 1 2 2 3, like these are the combinations are given. So can you tell me? Okay, let's check one by one. Okay, so if t is an unbiased estimator of theta, can t square be an unbiased estimator of theta? What do you think? Yes or no? So basically, by the property of consistency, we can say this one is absolutely true. If t is consistent for theta, then t square is also consistent for theta square. Like the previous sum which we have done in our class. So t is unbiased for theta does not imply that t square is unbiased for theta. Also, t is sufficient for theta does not imply that t square is also sufficient for theta. Okay, so basically these two are not true. So only two, the number statement number two is true. So that's why this will be the answer. Okay. Okay. Go for question number 24. Can you answer 24? They are saying that x1, x2, xn is a random sample from Poisson theta. Then I am considering two statements that x bar 1 by n summation xi is the MLE of theta, and 1 by n summation xi is the sufficient estimator of theta. So which one is true? Either both or scroll down a little bit. Yes. Either both or only one or only two or neither one, neither two. Which one you think is correct? If you can see that for sufficiency, this statement is absolutely correct. So 2 is correct. So we can exclude option 1 and option D, A and D. So from between B and C, we have to choose any one. So we need to judge for option 1 whether they are correct or not. The option 1 is correct or not. So basically, 1 by n summation xi is also the MLE for estimating theta. If you have already solved this problem, you will be knowing this. So basically, this option C is correct. Do you know, or shall I solve it and show it to you that how these two are becoming sufficient and maximum likelihood estimator? Am I audible?
Once show, ma'am.
Okay, so let us consider that x1, x2, xn be a random sample from Poisson. I am taking lambda. Okay, since I'm not going into that particular sum, I am taking Poisson lambda, and they are IID samples. Yeah, I hope you know the meaning of IID basically. So IID samples, so their joint distribution will be when lambda is greater than 0 and x runs from 0 to up to infinity. Okay, so this is xi for all I. Okay, this is my joint distribution. Now basically I am checking about sufficiency. Checking for sufficiency, what the formula of sufficiency said, that this f of x curl, if the joint PDF can be written as a function of this test statistic with a function of the parameter and with a product of a function of only the variable or the samples basically, then this particular t of x curl will be called sufficient for theta, the parameter theta. So I need to see that can I write this thing or can I write my f of x curl in this format. So e to the power n lambda e to the power minus summation xi by product over xi factorial. So if you can see, basically e to the power minus n lambda into e to the power minus summation xi, that I am putting together, and 1 by product over xi factorial. Okay, so if you can see, here lambda is involved. Okay, and here basically sorry, here lambda is basically involved. Here lambda is basically involved. Okay, so this portion I, and also a function of xi is over here, so this portion I can consider as g of t of x curl comma lambda, and this is a purely function of h of x curl. So which function is involving both lambda and this x curl? This is the function which is involving both lambda and my x curl. So that is my t of x curl is equals to lambda to the power, sorry, not lambda to the power, this this is basically summation of xi, I running from 1 to n. So and I can also modify it writing as x bar. So this is my sufficient statistics. This goes the part of sufficiency. Now going for the part of MLE, maximum likelihood estimator. So what was my f of x curl? E to the power minus n lambda, lambda to the power summation xi, product over xi factorial. This was my MLE, like the likelihood function. This we call the likelihood function. Okay, now we will take the natural log of this function, that is going to give me, so log of a by b is going to give me log of a plus minus log of b. So whenever I am taking log of a, this is actually going to give me this into log of lambda minus this thing. This is called log likelihood. Log likelihood function. Okay. After that, what we are going to do? We are going to do the derivative of this log likelihood function with respect to the parameter, the first order derivative. So if I am doing the derivative, I will be getting minus n plus summation over xi by lambda minus 0, that is basically equals to minus n plus summation over xi by lambda. Then what we have to do? We have to equate this first order derivative of log likelihood with 0, and we will be getting n plus summation xi by lambda is equals to 0. That means lambda is equals to summation xi by n, that is equals to x bar. This value we basically called lambda hat MLE is equals to X bar. So now, can I claim this? Can I write this? For checking, we need to check. For checking purpose, basically this is the broader way of doing the sum. Whenever you are going to do the objective, you have to remember this thing. For checking purpose, what we have to do, basically you have to go for a second order derivative of this log likelihood function. If you are going to do the second order derivative and going to put this lambda hat is equals to X bar, you are going to find a negative value for this. If this is satisfied, then only you can claim that yes, lambda hat MLE is equals to X bar. So hence, a lambda X bar is not only the maximum likelihood estimator of theta, but it is also the sufficient statistics for theta. So both statement 1 and statement 2 are true. Is it okay?
Yes, ma'am.
Okay, now going for some other sum. Let's see which are marked. Okay, this one. For a likelihood ratio test, you know these two are very obvious statements corresponding to likelihood ratio test, that the lambda used in likelihood ratio test is going to be within 0 and 1 or not. They are asking this thing. Next, they are asking that whether this will asymptotically follow a chi-square or not, and likelihood ratio test is consistent or not. Obviously, both the statement are all the statement are true corresponding to a likelihood ratio test. So obviously, option D is the correct answer. Okay. Next, going for okay. Let us try this 43. Oh, we have a random sample of size n from uniform alpha beta. So, and the MLE of alpha and beta respectively, what? Basically, summation xi square, product of xi square, minimum of x1 x2 xn or maximum of x1 x2 xn, or the x order n minus x order 1 by 2 or x order n minus x order plus x order 1 by 2. So, can you answer this question? Do you know what the method of finding MLE for uniform distribution?
No,
Like
ma'am.
for x, if x follows uniform alpha beta, so what is the basically the normal? Suppose a single random sample we are taking, a single sample. Okay, so fx will be 1 by beta minus alpha, and the range of x will be this, right? And if you can see my previous sum for Poisson, the range was independent of the parameter. So if the range of the distribution depends on the parameter, then we cannot use the usual method. Usual method means the method of derivative, basically. Method for finding Emily. Okay, so if you can see, like if I take the log of this particular function 1 by beta minus alpha, and if I do the partial derivative of this function with respect to alpha and beta 1 by 1, obviously it will be becoming 0 or 1, something like that. So I won't get any function or anything like that, which is I won't get any equation which will be giving me like alpha equals to something or beta equals to something, right? So obviously I can't use this derivative method for finding out my alpha and beta. So in that case, what we have to do here, since the range is over there, we need to use the like order statistic for our for our estimator, for the maximum likelihood estimator. So if I need to use order statistics, so obviously I can cancel out option A and option B. So I am left with option C and D, and I need to check that which one is the correct answer. So as you can see, alpha less than x less than beta. So for single sample. So if I have multiple sample, then obviously all the samples will lie between alpha and beta. And if I ordered the sample, then obviously I am going to have this thing. This will be my ordered sample. And obviously the ordered sample is going to lie between alpha and beta as well. This is my ordered sample, right? I am taking only the first one and last one. I am concerned about this one and this one. So that is giving me alpha less than x order 1 and x order n is less than beta. Okay, so can you tell me that from over here, if I take beta minus alpha, which function can act? Now the function is 1 by beta minus alpha. So what will be the combination or values of beta and alpha for which these values will get maximized? See this particular thing. See, beta minus alpha. If I take if so beta minus 1 by beta minus alpha, this function will be maximized if basically like tell me like which one is bigger, half or 1 by 4, which one is bigger? This one is bigger. So I need it. So beta minus alpha, the minimum value of beta minus alpha is going to increase this function 1 by beta minus alpha. So I need to take something which is going to decrease the value of beta minus alpha. So obviously I will take the maximum value of beta, and the maximum value of beta is x order n. So for Emily, I need to take the value of beta as x order n. So beta hat Emily will be my x order n. Now for alpha I need something which also for alpha I can take x order n, but since there is a minus sign before alpha, so any minimum value of alpha with the minus sign will actually going to maximize this particular function. So that's why I am going to take alpha hat Emily as x order 1. So basically this option C, this one is my answer. Is it clear? D is not my answer.
Yes, ma'am.
Okay. So we actually have came to the end of our class today. So I am doing the stop sharing right now and also the stop recording for today. So I will be sharing the PDF to sir's office. They will communicate with you.